Hello, welcome to six. Oh, let's not be there. Oh, I closed it. Uh-oh, hold on. Okay, welcome to 6.5 homework help. Here we go. This is my friend. He's just a panda. He's super soft. Okay, so what is a polygon? I gave you a definition for this in the notes today. So if you did not write it down or you were not here, you can go on Canvas on the sidebar, click on modules, M-O-D-U-L-E-S, click on modules, scroll all the way down to the bottom. You're in Unit 6, and it should say 6.5 lesson notes, all right? Or you can Google it. You can just Google polygon definition, and it'll tell you. Alrighty. I'll do some of these with you. Okay. So number sides and polygon. So fill in the names of each polygon based on number of sides. Okay. So a polygon, I also gave you the definition. A polygon is any shape with straight sides. The sides have to be straight, and it has to be closed. For instance, a square. Let me just. Oh, okay, fine. Or a rectangle. Sure. Oh, a rectangle is a polygon. The sides are all straight, and it's closed. Okay. An example of a shape that is not a polygon is a circle, right? A circle, okay, fine, or an oval, same thing. The sides are not straight, they're curved. So this is not a polygon. The sides have to be straight. The sides must be straight. Okay, goodbye. And then it has to be closed. So I'll sketch something real quick. So if I have something, pretend it's straight, like that, like that, like that. There, we'll leave it there. See, there's a gap. It's not a closed shape. It has a hole in it. Okay, not a polygon. All right. Anyways, so a polygon with three sides. Triangle. Triangle. Four sides, that's what we worked with in class on Friday or today, whenever you're watching this video. Those are quadrilateral. Tri means three, quad means four, like a quad. What are like those four-wheelers you guys ride, or some of you ride? Okay, four wheels. That's why it's called a quad. Five. What is a polygon with five sides? Pentagon. I don't really want to do all of these. Which one's kind of hard? 6 and 7. You can also Google these. Side of 9. I'll fill in 10 for you. 10 is a decagon. Okay. If you don't know these, that's okay. You might have forgotten them. You can Google them. Google will help you. Okay. So number 3 and 4, they want you to, well, not 4 so much, but number 3, they want you to look it up. What is a kite? So you can do this fairly quickly by searching online. So you're going to write down a definition of a kite, and then just do a little sketch of one. If you already know what it is, Google it anyway because I want a definition of it. So sketch it, and then give me a definition of what a kite is. All right. Once you have a kite, you're going to draw in lines of symmetry and the diagonals. So remember, diagonals, let me just grab a polygon here. We did examples of these in our notes. I don't know. Let's just do. Go there. And then there. We'll do a parallelogram. And then there. And then there. Okay. So diagonals just are lines that connect the opposite vertices. So vertex to vertex. I don't know if I can put a line in here. Oops, sorry. Oops, oops, oops. Let's see if it'll let me. Maybe I can draw it in. Yeah. All right. Sorry. Pretend it's straight. It's a straight line. So your diagonals, they just connect your opposite vertex. So you would do this with a kite, all right? Lines of reflective symmetry, those are lines of symmetry. So we did that in class today. Lines of symmetry are lines that if you fold the shape over on that line, it folds perfectly. Okay, for instance, look down at my little video in the corner. I had, what was this? Oh, okay, I had a rectangle. So I'll hold it up to the camera. Here's my rectangle. This is called a perpendicular bisector of the sides because it's perpendicular to this side and it bisects it, cuts it in half. Anyway, you can also just, that's vocabulary, you're cutting it horizontally. If I fold along that line, it fits perfectly on itself, right? So that is a line of symmetry. That's one example. An example of a non-line of symmetry is actually on the back. Okay. This is one of the diagonals of a rectangle. If I fold along this diagonal, will it fold over perfectly onto itself? Oh, I think I folded this one already in class. No, it does not. See how this is sticking out? It does not fold over perfectly onto itself. So that is not a line of symmetry. Okay, go look at the notes from Friday on Canvas. We did 4 examples, 4 different shapes. Okay, so you're doing that, but with a kite. Okay, rotational symmetry for a kite. So it's either going to be, I'm not going to tell you what it is, but it will either be 90 degrees, 180, 270, 360. Okay, those are the degrees we're looking for. So if I rotate a kite 90 degrees, so if I have a rectangle, okay, I'm going to rotate 90 degrees. I'm going to rotate it 90 degrees. Wait, I mirrored. Did I do that right? Yeah, that's 270. Okay, rotate it 90 degrees. So it would not fit on itself. Where's another rectangle? I know I have another one somewhere. There it is. Okay, so here are my original rectangles. If I rotate it 90 degrees, okay, it does not fit. If I rotate it 180 degrees, now it fits. So for a rectangle, 180 degrees is rotational symmetry. But you're doing a kite. Okay, 270 is just like that, and then 360. 360 works for everything. 360 means you rotate it all the way around, and you're back to the beginning. Like if you do, I think it's a trick. I swear it's a trick. On like a skateboard, you can do a 360 where you like spin all the way around. Okay. So I'm not going to tell you what it is. You have to figure it out. Are lines of symmetry also diagonals in a polygon? Sometimes. Sometimes they are, but not always. And then explain why. Okay, so once again, I would look back at our notes for today. Were all of our diagonals lines of symmetry? If you were not in class, please go look at the notes and you will be able to tell, hopefully. Are all diagonals also lines of symmetry? Okay, so very similar questions for 6. Oh, they have 2 6s? Yep. Oh, no, that should be a, nope, that should be a 7. I don't think I can fix it. Nope. Okay. You have 2 number 6s. And then number 7. Which quadrilaterals have diagonals that are not lines of symmetry? Name some and draw them. So once again, I would go and look at the notes from today. I guess I can do one example. We just did an example with the rectangle, right? Where was it? Where'd it go? Nope. Yep. Okay, here's my rectangle again. This is the diagonal. Oh gosh, being mirrored is hard. This is my diagonal line. Okay. Is it also a line of symmetry? No, we figured out that it wasn't. If I were to fold my rectangle on this line, it does not fold over onto itself. Right? Remember that? It does not. So no. So that are not lines. So rectangle is one. What are some other quadrilaterals where their diagonals are not lines of symmetry? All right. Okay, here we go. 9 through 11. I did number 9 for you as an example. Okay, so they give you an equation of a line for number 9. Y equals 4x plus 1. You have to find an equation of a line parallel and through the indicated y-intercept, and then perpendicular and through the indicated y-intercept. Okay, so your equation for a line, y equals mx plus b. M is your slope, b is your y-intercept. So they give you the y-intercept. They always, on all the problems, they give you the y-intercept. So parallel lines have the same slope. So that's how I got my 4x here, because they have the same slope. And then the y-intercept is -7. So -7. So I just filled in my equation. Perpendicular, for perpendicular slopes, that's when you flip and switch the slope. Remember, they are opposite reciprocals. So my slope was 4, which is the same as 4 over 1. And so I flipped and switched the sign. So it became 1/4. And switched the sign, so that's -1/4. All right, and then my y-intercept is still -7. All right, so for number 10, oh no. You have to figure out what the slope is. So if you want, you can graph these points and then look for the slope. That would work. Or what's the change in y? And then, okay, so your change in y, -8, -10, -12, -10. So my change in y, I'm going down by 2. My change in x, 3, 4, is I'm going up by 1. All right, so my slope, -2 over 1, which is just -2. So now that you know your slope, you can go ahead and write your equation for a parallel and a perpendicular line. Okay. And number 11, they give you a graph, so you can figure out the slope from the graph. Alrighty, that's your homework. Have fun.